Yeah, good morning, boys and Pallavi. We are back with our favorite chapter, Biomolecules. And as I said yesterday, these are the chemical substances that are present in our tissues, in all the living tissues, in the living organisms. Whatever food that we consume in the form of breakfast, lunch, dinner, snacks, Naveen? We call it BLD, no? So, all these will be in the form of carbohydrates. Like when Pallavi is consuming rice, what exactly she is eating is carbohydrate. When you are eating sweets, okay, which is made up of sugar, sugar is a carbohydrate. Bread and butter, Pallavi's favorite, as again bread, bun, biscuits, these are all basically carbohydrates. So if you analyze, as I said in my previous class, whenever you are consuming your breakfast, lunch, dinner, snacks, if you analyze, you will understand that most of the South Indians eat lot of carbohydrates, whereas the North Indians, the other side, they consume more of fats and proteins. And that is the reason why we need to have a balanced food. And way back in junior classes you have studied, balanced food is the one that contains all the nutrients in required quantity. Required quantity, for me, my quantity is different at the age of 58 to Naveen, who is 16 years, right? So, depending upon the work that we are doing, nature of work that we are doing, like I am a teacher, I teach. So I spend little bit of energy compared to a laborer who is doing labor work from morning till evening. So depending upon the profession, depending upon the age, okay, our requirements keep on changing. And proteins, the most important ones, I said, and they are taken in by all of us in the form of green peas, okay, and all vegetables and fruits, white of the egg, milk itself. That's why all vegetarians, you should drink a lot of milk. Okay, can someone name the protein that is present in the milk?
Calcium.
Yeah, calcium is a chemical element. I am asking protein. Name the protein that is present in the milk. All of you are drinking milk every day? At home? When you are in cadets mess, of course, every day you are drinking. So you are drinking without knowing what is the protein present. Is it?
Yes, drinking.
You are only drinking, but not trying to know what you are drinking. Right? Any idea? Name the protein that is present in the milk. No idea? Anyone? Pallavi? Don't know? Lactin. Okay? Lactose is the sugar molecule. Lactin is the protein. And what about egg? White of egg? What is the protein that is present? All eggarians, those who are eating eggs. Any idea? Anyone in the class? That means class 11th, you eat, but you don't know what you are eating, right? So that is the purpose why we are introducing this chapter, biomolecules. You must know what to eat and how much to eat. That is the purpose. And once you know the functions of each biomolecule that is present in us, you understand the importance of consuming those biomolecules. Isn't it, Naveen?
Yes.
So tell me now, what is the protein present in the white of the egg?
Oval protein.
Anyone? Raghavendra? Raghavendra, do you eat egg?
Yes, sir.
Then tell me.
Oval means
Albumin. What is that? O-albumin. Albumin. Okay? That is the protein content that is present in the egg, that white of the egg. But inside Raghavendra, when he consumes, there is small TT ball inside the egg. The TT ball is fat content. So when you are consuming egg, you are consuming both fats as well as proteins. Understood? Similar is the case with the milk. Sugar is there, lactose, that's a carbohydrate, but lactin is a protein, right? So how to know which are the chemicals that are present? Like yesterday we said, you take a leaf, grind it, filter it, and analyze the filtrate, you will come to know what are the chemicals that are present. And basically there are two types of biomolecules present as far as their weight is concerned. And the weight is measured with the unit called Dalton. All those biomolecules which are just below the 1000 Daltons molecular weight, we call them as microbiomolecules. Micro means small sized ones. And above 1000 Dals, we call it as what do you call? Mega or macro biomolecules. Okay, a molecular weight is above 1000 Daltons. And we have compared what are the various elements that are present in the earth's crust and in our own tissues, right? And we also talked about the most important biomolecule, microbiomolecule called amino acid. And I also said amino acid is a monomer, and when many amino acids join together, they form protein. So just now I said the albumin present in the egg, lactin present in the milk. These are proteins, and those proteins are formed due to combination of amino acids. So only we said amino acid is a monomer, protein is a polymer. So polymer, as the name suggests, poly means many, units of amino acids. Like amino acid 1 combines with amino acid 2, then that is a protein. Amino acid A plus amino acid B plus amino acid C, that's a protein. Again, like in your mathematics class, they say permutations and combinations. In different ways and forms, amino acids combine and form n number of proteins in our body. All these are important. But basically you must understand that any amino acid will have centrally one carbon atom, right? That's called alpha carbon. And that carbon atom has got 4 valence electrons, means lone electrons. They are not paired. That is the reason why we say valency of carbon is 4. That means the lone electrons present, 4 in number, can combine with 4 other substances forming bonds. Okay, not James Bond, covalent bond. Here 2 groups are there. Compulsory in any amino acid, 2 groups will be present. One is the amino group, we call it NH2 group, right? NH3 is ammonia, you remove one hydrogen, NH2. So that is amino group. And the second one is COOH. You can see in the picture C double bond O and single bond OH, right? COOH, that is hydroxyl group, carboxyl group, right? Okay, Rahul is admitted, right? So let me expand. Yeah, you can see the amino group, NH2 group, and carboxylic acid group, COOH. One oxygen atom with a double bond, another hydroxyl is single bond OH. And third one is the hydrogen atom, as you are saying, and the fourth one R is written, that is variable group. So it can be any functional group. So that functional group will make each amino acid different. How different? Look at this. In serine, it is R is equal to CH2OH. Other things are common, other 3 are common. NH2 common, COOH common, and H is common. And in case of alanine, it is CH3, methane. Methane is the functional group. In case of glycine, one hydrogen atom is the R group, variable group. So in glycine, remember glycine is an amino acid. In its three are normal, COH group, NH2 group, hydrogen, and the one that is shown with red color is the variable group. So in glycine, that functional group is simple one atom of hydrogen. And there are 20 types of amino acids that are present in our body, and based on their nature, we said some of them are acidic in nature. Okay, example glutamic acid. Some are basic or alkaline in nature, example lysine. And the third one is neither acidic nor alkaline, they are neutral, example valine, right? And some of the amino acids are aromatic, means they give nice fragrance. Based on the nature of amino acids, they are classified into essential amino acids and non-essential amino acids. What are essential amino acids? These cannot be synthesized by the body and should be supplied through diet. I hope you understand the importance of diet here. So these amino acids, which are called essential amino acids, they need to be, see the word essential says everything. We require them, we need them, they are very essential for us, but they cannot be synthesized in the body. So when we can't synthesize these amino acids, what is left option? Left out option is we need to intake through our diet. And that is the reason in the beginning of my class I said every one of us should know what to eat and how much to eat. And where our diet should be invariably, predominantly with the fruits and vegetables. That too, fresh fruits and vegetables. Don't consume rotten ones, right? You know the difference between fresh one and the rotten one. Smell will be there, foul smell will be there. So the moment you smell the food, you know whether the food is fresh or spoiled. So if it is smelling badly, don't eat, throw it out. So essential amino acids are to be taken through our diet. Example lysine, lysine, isoleucine and tryptophan. You can remember at least one or two amino acids. And non-essential, they can be synthesized by our body. So our body has got the ability to synthesize these amino acids such as glycine, alanine, serine, arginine. So only showing you in the picture itself, right? So there is no problem with this. Our body can prepare ourselves, right? So in amino acids, as we discussed just above, NH2 and COOH have ionizable. Ionizable means forming ions, charged particle. What is an ion? Charged particle. Like for example, Na, you take sodium. When we say Na, it is atom of sodium. When we say Na plus, it is ion, okay, or radical we say. Any atom that has got charge, either plus charge or minus charge, is called ion or radical. Okay. Here in amino acids, NH2 group, amino group and carboxylic group, COOH, have ionizable nature. So structure of amino acids changes in solution of different pH. All of you understand what is a pH. We can define pH as negative logarithm, negative log. You know, in mathematics you use log and anti-log. So when I say negative log, it is anti-log, anti-log of H plus ion concentration. And that can be measured in a pH scale. And yesterday I said in my previous class, a pH scale ranges from 0 to 14. 0 to say 6.9 or almost 7, we say acidic in nature. Any substance that fits in this range 0 to 6.9 we say acidic. 7 exactly is the neutral. 7.1 to 14 is the alkaline nature. So that's how we measure with the help of pH scale whether a substance is acidic in nature, neutral in nature, alkaline in nature. Clear? So if both these, like I said, ammonia formula you know NH3, okay, and if you remove that hydrogen it becomes plus, NH2 plus, and COOH, remove that H, COO minus it becomes. And since both ammonia as well as carboxylic groups are in ion form, now look at that, this is a reversible reaction. When arrow marks are shown on both the sides, you should understand that it is reversible. I am sure in chemistry you have studied reversible reactions. And it forms, the amino acid forms what is called zwitteronic form or Zwitter ion. It's named after the scientist who discovered this, Zwitter. So Zwitter ion, and Zwitter ion is formed, you can see, with the charges NH3 plus and COO minus. And you can see here the ammonia group NH3 is losing one hydrogen, becoming NH2, and COOH group is losing one hydrogen, becoming COO minus. So this is how ionization takes place in the amino acid, and ionization leads to formation of Zwitter ion, right? So sometimes he will ask you in the exam, what is Zwitter ion? So you need to draw this diagram and explain. So that's about amino acids, and you must understand that they are very, very important for us, particularly essential amino acids. You need to consume them. You need to supply to your body through diet, and that is why diet plays a crucial role in our life. Most of the diseases, like maybe in junior classes you have again studied PEM, protein energy malnutrition. Remember? To avoid that PEM, protein energy malnutrition, we need to take a lot of proteins inside our body. And remember, we must be thankful to God because we are able to get what we want. There are thousands of children, in fact lakhs of children, particularly in Africa, where a 2 square meal is not available. They don't have 2 meals a day, they have just one. Even in India, our own country, parts of some of the areas like Orissa, there is no food available to some children, unfortunate children. So be thankful to God that we are all getting it, and if possible, help them, help those who are helpless. Okay? Lipids, second, biomicromolecules, and you know lipids are nothing but fats. And what do they contain? They are water insoluble. You know that oils and water they don't mix up each other. Water insoluble. Like whenever you take some glass of water and put 1 or 2 drops of coconut oil on that, see if you can mix it. However you try, the oil layer will be on the top. You must have seen on a rainy day on the roads when a lorry passes and there is a leakage of engine oil that falls on the water accumulated on the road. You can see different colors on the surface of water, isn't it? So that shows lipids or fats are insoluble. And what do they contain? They contain carbon, hydrogen and oxygen. Along with this, there is something called fatty acid. Fats, fatty acid. They contain fatty acid. And oxygen atoms are less. And what are the lipids? In what form we can see lipids or fats? All oils without exception. Cheese, butter, ghee, right? All these are lipids. And we have, based on their structure, we have 3 types of lipids. We classify lipids into 3 types: simple lipids, compound lipids and derived lipids. You can see the simple lipids, compound lipids and derived lipids. In what way we are able to classify that? Look at that, simple lipids. These are formed, as I said just now, fatty acids and alcohol like glycerol. Remember, it is alcohol like, not alcohol. So you must remember, any lipid or fat is made up of two chemical substances, fatty acids plus glycerol. Right? Glycerol normally it is used by your cinema heroines. Whenever they have to cry, they put one drop of glycerol in their eyes and water will come out. When the heroine cries, Naveen also cries, isn't it? So these are formed of fatty acids and glycerol. And fatty acids are lipids with hydrocarbon chain, and that group is called R group, ending with COOH group. So we write fatty acid as R-COOH. Like down he has given the example of palmitic acid. How many carbons? 16 carbons. So the structure, how you are writing? CH3, CH2, how many times? 14 times COOH. That is the formula of palmitic acid. And it can also be written as, because you are adding the CH3 group in that. So CH3, CH2 14 times, so you combine that, it becomes 15, carbon becomes 15, C15, H31 and COOH, there C is there in COOH. So totally 16 carbons. And arachidonic acid, further 20 carbons. So these are having such a big number of carbons, and remember, they are simple lipids. Okay, look at that. And don't forget that COOH, that's compulsory. And you know, CH4 is methane. CH3 you are knocking out, you are removing out one hydrogen. So CH3 methyl group. Then in that simple lipids only, you got the two types again. Saturated fatty acids, they have no double or triple bonds between carbon atoms. That means you must have seen some molecules will be having within them either double bond or triple bond. And I'm sure in chemistry, your chemistry teacher must be telling you CH4, methane, centrally carbon, and all the four angles, one hydrogen. All are single bond, CH4, methane. But you must have seen your teacher writing C2H2, carbon, carbon, and in between the carbon, two bonds will be there, right? Double bond will be there. And he calls it ENE, like he says ethylene, right? And when there is a triple bond between carbon, carbon, then you say YNE, like ethylene, LYNE. So depending upon the bonds, how many bonds are present, the spelling also varies. But in saturated fatty acids, there is no double bond or triple bond. You can see the example he has given, stearic acid, having 17 carbon atoms, 35 hydrogen atoms with the COOH functional group. Look at that. Nowhere you see double bond. Carbon, hydrogen, all single bonds, right? Stearic acid. And the example is the rice that you are eating. What about unsaturated? All the oils that we consume. In fact, I was reading somewhere that most of the diseases that we get is because of the oils that we consume, particularly palm oil. Be careful. Do not consume palm oil. And particularly when you go to hotels for your food, okay, basically palm oil is a cheap one and it's not a cleaned one. So the hotel owners across the country will be using this palm oil. And on consumption of this food items cooked in palm oil will give us a lot of diseases, particularly heart related diseases. Hence, unsaturated fatty acids are very, very dangerous. Why? They have either double bond or triple bond. That is why they are unsaturated, means they are not saturated. There is no single bond, double bond, triple bond is there. On availability of any other substance, what these fellows will do? They will break the double bond and triple bond and form combinations. That is the problem for us. So, example, oleic acid, C17H33COOH, and arachidonic acid, C19H31COH. So, soon after my class, what you do? Just Google it. Go to Google Baba, ask him what are the unsaturated fatty acids that are present in palm oil. Okay, in all the oils that you are consuming. Maybe being North Karnataka boys, you must be using, your mummy must be using sunflower oil, isn't it, for your cooking. So just see what are the good substances present and what are the bad substances that are present. And when you consume those, what will happen? So next somebody like our Pallavi will ask, sir, फिर खाना कैसे? क्या खाना है? Isn't it? If everything is dangerous that we are consuming, then what to eat? There comes our wisdom. Biology boys, biology students must understand what are to be consumed so that we will be healthy. And it is our responsibility also to tell others, non-biology students, that what to consume so that they will also be healthy. It is not simply just for the sake of exam, all of you study, mug it up, vomit in the exam. No, that's not the purpose, right? At least as far as biology is concerned, I insist that whatever you study should be useful in your day-to-day life. Not only for you, family, for the society at large. Okay, keep this in your mind. So a simple lipid, as we said, having single bonds, CH2OH, CH2OH, CH2OH. And this is the structure of glycerol. And what is the name of that chemical name? Trihydroxypropane. When we say propane, look at that, how many carbons are there? Your chemistry teacher must have told you propane, 3 carbon. Yeah. Methane, 1 carbon. Ethane, 2 carbon. Propane, 3. See, CH2, first 1 carbon, middle 1 carbon, last 1 carbon. So this is the structure of glycerol, and this is part of the simple lipids, right? And for the fatty acids are esterified. Again, there is a reaction called esterification. Esters are formed. So fatty acids are esterified with glycerol through ester bond, forming monoglyceroids, diglyceroids, and triglycerides. So what is mono? As the name says, mono means one glycerol only. 1 glycerol plus 1 fatty acid, that is monoglyceride. Di, as the name suggests, 2 glycerides, 1 glycerol plus 2 fatty acids. And triglyceride, 1 glycerol plus tri means 3 fatty acids. And look at that, in palmitic acid, we were talking about palm oil now, look at that. So you can see that red labeled one molecule of water is coming out, OH plus HO. Okay, so glycerol plus fatty acid. You can see there, see the number of carbon atoms. So after my class, you practice once all these bondings. And the functional groups, R1. Okay, examples of monoglyceride, diglyceride, triglyceride. And triglyceride example is giving. See the structure. And here in this diagram you can see R1, R2, R3. Those are fatty acids. R1, R2, R3 are the fatty acids. And look at that, just now I said your cooking oil. Like in Kerala, if you go to Kerala, invariably they cook food with coconut oil, right? Whereas in North Karnataka, you must have seen in your own kitchen, your mummy using sunflower oil or groundnut oil, isn't it? And let me expand this. Look at that. 3 fatty acids. Okay? Glycerol is the backbone. So 1 glycerol plus 3 fatty acids. I hope you understood. Look at that. So which one will take a lot of time for us to digest? Yeah, yes, 3 fatty acids. You see? So monoglycerides are easy to digest. Triglycerides, see, 3 fatty acids are to be dissolved by us. Hence, this is the problem. And maybe in my next class, I will talk about compound lipids. We'll see that. Today you got a lot of work. You need to draw these diagrams. And in our WhatsApp group, as usual, put a thumbs up after completing the work. Already I have posted this to you in the group. I hope you have downloaded it, you have gone through it, and just draw all the chemical formulae that we have studied. And check, as I said, I have given the homework through Google Baba. First identify what is the cooking oil that your mother is using. Identify the dangerous chemicals in that and good chemicals in that. Depending upon that, educate people around you and take care. Be healthy always. Bye bye.